Now we want to talk about reference angles. Reference angles are going to be extremely helpful for many of the things that we'll be doing throughout this the rest of this course. Let's read the definition. A reference angle for an angle theta, written as theta prime, this is a little prime mark here, is the acute angle made by the terminal side of angle theta and the x-axis. So what is this saying? Let's draw a picture. So let's say my angle theta, we know it's going to start here for the initial side because it's in standard position. And maybe this one goes over here to maybe it's over here in quadrant 2 like this. The reference angle is the distance from, or is the angle measured between the terminal side of angle theta and the closest or the shortest distance to the x-axis. So theta prime is going to be here. It's going to be from here to here. Okay. Another way this might look, if we were to draw our angle theta beginning with our initial side on this over here, and then maybe it's going to come around to quadrant 4. So this is angle theta. Theta prime is the angle that goes from the terminal side of the original angle to the x-axis. So the shortest distance from the terminal side of angle theta to the x-axis would now be from here to here. So this would be theta prime. These reference angles are going to be really helpful when we start looking at the unit circle. We have a little fact that we'll mention. Reference angles are always positive and they're always between 0 and 90 degrees. So just depending on what quadrant you're in, you're just always looking for the shortest distance from your terminal side back to the x-axis, and it's always going to be a positive acute angle. Let's look at example 4. Find the reference angle for each angle. Part A, our angle is 110 degrees. Okay, so an angle of 110 degrees, it's in standard position. It starts on the right side of the x-axis, and then it's going to go up to here would be a 90-degree angle, and then I need to go another 20 degrees into quadrant 2. So 110 degrees is going to look like this. Okay, so here's theta from here to here. Theta prime is the shortest distance from the terminal side back to the x-axis. So theta prime is going to be from here to here. Now how can we calculate that amount? Well, we know that it's 180 degrees all the way back to the x-axis again. We just need to subtract out the 110 for the original theta. So if I do 180 minus 110, that gives me an angle of 70 degrees. And just like many other things that we do in this course, there's more than one correct way to get the answer. So if you're thinking about it a different way, don't worry, that's probably okay. Part B, 210 degrees. So we want to draw 210 degrees first. If we start on the x-axis, here is going to give us 90 degrees, and then this is 180 degrees back to the x-axis again. We're going to be going into quadrant 3 to get to 210. So if I'm at 180 degrees here, I need to go another 30 degrees to get to the terminal side of my angle. So this is theta, and it was 210 degrees. We need the shortest distance from the terminal side back to the x-axis. So we need to go from here back to here, because that's the shortest distance from the terminal side of our angle back to the x-axis. So because it goes from here to here, we need to do the 200. We can think about how we can calculate that angle from here to here. This is our theta prime. So it's going to go, this original angle was 210, and if we subtract this first part back here, the 180, that's going to give us theta prime. So we can do 210 minus 180, and that gives me an angle measure of 30 degrees. So my reference angle is 30 degrees. Part C. So we want to find 255 degrees first. So we start here at the initial side, we go to 90 degrees, 180 degrees. If we go all the way down here, this is going to be 270, and that's too far. So we need to back up about 15 degrees, right about maybe a little bit more like this. So theta goes from here all the way around into quadrant 3. So looking at my picture, I need to determine how to find my reference angle. What's the shortest distance from my terminal side to the x-axis? This is similar to part B because it's going to be the distance from here to here. So what is that difference? That's 255 degrees. Let's subtract this 180 degrees. So 255 minus 180. And how much does that give us? Let me pull out my calculator. So 255 minus 180. That's a difference of 75 degrees. So my reference angle is 75 degrees. For part C, this time we're doing 294 degrees. Alright, now 294 degrees was going to get us, this is 90, this is 180, this is 270, and then we need to go another 24 degrees over here, so it's going to be similar to this. So my terminal side is now in quadrant 4. I still need to find the shortest distance. Oops, I'm sorry, there's your picture. I need to find the shortest distance from the terminal side to the x-axis. I'm going to find that by going from here to here. So this angle is going to be, how can we calculate this angle? We know that this one was 294 degrees. So if we do the complete circle, the 360 minus 294, that's going to give us a difference of how much? 360. I don't know if you can see that, but I'm just punching it in. 360 minus 294, 66 degrees. So my reference angle is 66 degrees. For part E, I've got an angle of 883 degrees. Okay, it's going to be helpful here if we start with a coterminal angle that's as close as possible to 360, closest possible to 0 and still positive. So we want to get it under 360. So the coterminal angle for this, you can just subtract 883 minus 360. Minus 360. That's 523. Let's subtract 360 again. That's 163 degrees. So I'm going to use a coterminal angle of 360 degrees. Oops. Ooh, that's not right. I'm sorry. 163 degrees. I don't know why I said that. It left me with 163 degrees. Okay, so all I did was I said 883 minus 360 and minus 360 a second time, and I got 163 for my coterminal angle. So that's easy to draw. 163 is going to bring us to, here's 90 degrees. This would be 180, so I'm going to be back here somewhere in quadrant 2. I know that this is 163. So I need to know the difference, or the distance from my terminal side to the x-axis here for theta prime. And how can I calculate that? Let's do 180 minus 163, and that is going to give us 17. So our reference angle for 883 degrees is 17 degrees. So reference angles are not hard. You just have to always, just remember that you're always comparing to the x-axis. You're always looking for the shortest distance from the terminal side back to the x-axis, and they're always going to be positive. It's a way of simplifying something that's a lot larger to work with into something really basic, and then being able to go from there. So reference angles are really going to be very helpful for what we'll be doing. Alright, let's look at page 9. Find the values of the 6 trig functions of 225 degrees. Okay, so let's first find a reference angle for this. This is going to be much easier to work with. We're going to find the reference angle. Alright, and then we can determine the signs of these trig functions by using all silver teacups. And use all silver teacups to determine the signs. So what is let's draw a picture. 225 degrees, we might have done it on the previous page, I'm not sure. But 180 will get us back to here. And then we need to go another 45 degrees to get the 225, like this. Okay? So 225. Okay. So what's the shortest distance to get from the terminal side back to the x-axis? Well, it's going to be from here to here. And because we had to go 45 degrees beyond the x-axis, so if you do 225 minus 180, that gives us 45 degrees. So we're going to use 45 degrees for our reference angle. That means that we can find sine, cosine, tangent, cosecant, secant, and cotangent using the 45 degrees instead of having to use the 225 degrees, and it's easier to do. So our reference angle is 45 degrees. And I'm going to first go through and do my calculations, and then I'm going to determine my signs. So we're going to do sine 45. All right, so what is sine of 45? Well, that one's going to be square root 2 over 2. Okay? What is cosine of 45? Okay, so in order to get this, you can be looking at your unit circle, or you can be looking at the table that we did together earlier in our notes in this section. I'm going to pause for a second while I find my unit circle. Okay, so on the unit circle, we are finding cosine 45. So here's my 45 degrees. Cosine, remember, is the x-coordinate, so square root 2 over 2. Tan of 45, remember that one is going to be the y value over the x value. So I'm on the unit circle, here's my 45 degrees. If I do y over x, they're the same thing, so they're going to reduce and give me a value of 1. So tan 45 is 1. And then I want to do cosecant. That's going to be my reciprocal, 2 over square root 2, which has to be rationalized. So if I rationalize my denominator, I'll do square root 2 over 2, square root 2 over square root 2. So I get 2 square root 2 over 2, and that reduces to just square root 2. So cosecant is square root 2. Alright, secant is the same thing because it's also the reciprocal of that original square root 2 over 2. So secant is also square root 2. Cotangent is the reciprocal of 1, which is also 1. Okay, now I keep saying that there's more than one way to do these types of problems, and that's true. You might have been wondering, well, why couldn't I just look at the unit circle and just read it directly from the unit circle without having to bother with the reference angle? And before I go any further, let me finish this up because I didn't get my signs yet. So let's go back and look at the we need to think about our all silver teacup so we can decide where the positives and the negatives are. So let's do that first, and then I'll talk about what I was going to say. So starting in quadrant 1, we know that all silver teacups, because our angle is in quadrant 3 down here, that means that only tangent and cotangent are positive. So tangent and cotangent are positive. All the others are going to be negative. So we'll come over here. These two are going to be positive, but all the other ones need to be negative. So cosecant should be negative square root 2. Let me rewrite that. Negative square root 2 for cosecant. Secant is also going to be negative square root 2. So I apologize that it's all running together now. Negative square root 2 there. Is that showing up? Negative square root 2. That is a negative. So sine is going to be negative square root 2 over 2. And cosine is negative square root 2 over 2. Now, you might be wondering, okay, why did I have to do the reference angles and have to worry about all silver teacups when I could have just read it directly from the unit circle? Well, let's find this. Remember, 225 was way down here in quadrant 3. Okay, and you're right, you could read sine and cosine directly from this. But how much of the unit circle are you willing to memorize? If you only memorize the first quadrant, you'll be able to get everything else using your reference angles and your all silver teacups, because it'll just fill in the rest of the chart. So if you enjoy memorizing and you prefer to memorize the whole unit circle, then go for it, and then you can just pick the values right off wherever you need to. But the reference angles and the all silver teacups will cut down on the amount of memorization that's required. Okay. Example 6. Find the exact value of each expression. We're going to do cosine of negative 240 degrees. Okay, so I'm going to first draw the picture. Remember, your negative angles are going to go clockwise, so you're still going to start from the same initial side, but instead of going this way, now you're going to be going this around this way. So negative 240, this is going to be negative 90, this is negative 180, and then negative 270 would be back up here at the y-axis, but we're not going to go all the way to 270, we're just going to 240. So we're going to go this far and draw our angle. Okay, let's do the same thing we did before. We need the reference angle. All right, my reference angle is the distance from my terminal side to the x-axis, and because this was 30 degrees shy, well, you can do it different ways. If you want to say 240 minus 180 like we did before, you can think of it like that. You can also say that, well, we know that if we had gotten all the way up to here, that was 270, and this is 30 degrees shy of that. So you could think of it as 90 minus 60 to get this piece in here. However you want to think about it, but just know that it's from here to here is what you're looking for. That's theta prime. Okay, so 240 minus 180 is going to be 60. So your reference angle is 60 degrees. And from here, is it going to be positive, negative? So we think about all silver teacups. Our angle is in quadrant 2 here, and this is the S quadrant, so that means sine and cosecant are positive. Okay, we were asked to find cosine, so cosine is not positive in quadrant 2, so our answer is going to be negative. And if we know the cosine of 60, we'll make that answer negative, and we'll have it. So cosine 60, and we're going to make the answer negative. What is cosine of 60? So this is where you need to have all this stuff memorized. Cosine of 60, you can go to your unit circle if you need to. Oops, that's not it. Sorry. Here's my unit circle. So go to 60 degrees. All right, 60 degrees is here. Cosine is the x value. So cosine of 60 degrees is 1/2. Ours is going to be negative 1/2. And that's our answer there. Part B, very similar. We want to find the exact value of tan of 675 degrees. So we'll draw our picture. All right, I would recommend starting with a coterminal angle here. So on your calculator, you can take the 675, subtract 360. That gives you 315 degrees. So that's your coterminal angle. So the coterminal was 315. So we're going to draw our coterminal angle. It goes all the way around. This one's positive, so we're back to counterclockwise again. Okay, that's going to be 270, and back up here would be 360. We want 315, so we're going to be somewhere in the middle in here. What's our reference angle? If we do 360 minus 315, that's going to give me 45 degrees. Okay, so my reference angle is 45 degrees. So from here to here, that's 45 degrees. Okay, so we've got a reference angle of 45 degrees. We're asked to find tangent. Okay, well I know because I've memorized tan 45 is equal to 1. Okay, how do I know that? Look at your unit circle. Go to 45 degrees. Remember, tangent is y over x, so it's going to be this divided by this. They're the same thing, so that's going to give you a value of 1. So tan of 45 is 1. What is the sign? Is it positive or negative? All right, our angle is in quadrant 4. We're going to say all silver teacups. Quadrant 4 is going, you're going to have cosine is positive because you've got C. Cosine and secant are positive in quadrant 4, and everything else is negative. So tan is going to be a negative. So we can say negative tan 45, so our answer is negative 1. Example 7. So I'm on page 10 of the notes now. Find all values of theta if theta is in the interval from 0 to 360 degrees and cosine theta is equal to negative square root 2 over 2. So if you're in the interval from 0 to 360 degrees, that just means that you're only interested in a single rotation. You're not interested in going beyond 360 degrees. So this answer can be found directly by looking at the unit circle. All you have to do is find all the angles on the unit circle where your x-coordinate is negative square root 2 over 2. All right, but you're going to have to be able to do this without looking at it. So again, if you've got your first quadrant memorized, you can figure this out using reference angles and all silver teacups. So you should remember, as hopefully, if not now, you need to remember this soon, that 45 degrees has, on the unit circle, 45 degrees has sine and cosine values both of square root 2 over 2. Okay, so that means that cosine of square root 2 over 2 is 45 degrees, and sine of square root 2 over 2 is 45 degrees. So that gives us the actual square root 2 over 2. We know it's happening at the 45 degree angle. All we need to do now is decide when is it positive or negative. So because we know our reference angles, we know that over here we've got another, if we come over on this side and put another reference angle, also at 45 degrees, that point on the unit circle will have the same sine and cosine values, not if we don't think about the actual sign, the positive negative part of it. In other words, the absolute value of these are going to be the same. We just don't know whether it's positive or negative yet. So it's either going to be plus or minus square root 2 over 2, plus or minus square root 2 over 2. And what is this angle over here? Well, it's 45 degrees. The reference angle is 45 degrees away from the x-axis. So 360, so you can say 180 minus 45 That's 135 degrees. Okay, so this one is 135 degrees. I'm going to do it this way, 135 degrees. All right, and then down here, at 45 degrees, another 45 degrees on the across the x-axis down here. So this one also has reference angle 45 degrees, and the value of this angle all the way around here, it would be 225. And this one also has the same sine and cosine, except we don't know if they're positive or negative. And then going back around, there's another angle over here that's another reference angle. So it's again 45 degrees away from the x-axis. And this one is 315 degrees. And it still has square root 2 over 2, square root 2 over 2, but we don't know the positive or negative yet, so we don't know if they're plus or minus. Now, so long story short, our answer is going to be one of these, or one or more of these four angles. All right, so how do we know which ones they're going to be? Because all of these have cosine of either positive square root 2 over 2 or negative square root 2 over 2. We just need to figure out which ones have negative cosine values. And we'll do our all silver teacups, and that'll give us our answer. So all silver teacups. So which ones have negative cosine values? All right, here cosine is the x-coordinate is positive, so it's not here. Over here, sine's positive, so that means cosine is negative. So we can choose this one. Here, tangent is positive, so that means cosine is going to be negative. So we can choose this one. And back down here, cosine is positive, so it's not there. So because we are asked to find the negative, we're asked to find the angles that have a cosine of negative square root 2 over 2. It's going to be here and here. So 135 degrees and 225 degrees are our answers. And they're both inside this interval. All right, now, if you're not grasping everything that I've shown you here, you've got your unit circle to look at. Okay, so all you've got to do is find the angles that have x-coordinates or cosine values of negative square root 2 over 2. So you can see it happened here at 135 degrees, and it happens here at 225 degrees. All right, over here when you're in quadrant 4, cosine is positive, and we were asked to find the negatives. So you have to, that one's not going to be included. And then in the first quadrant, cosine is again positive square root 2 over 2 at 45 degrees. But if you can see, if you can understand though that this is the original 45 degrees here, and then you had a reference angle, or let me rephrase that. The 135 degree angle and the 225 degree angle and the 315 degree angle all have the same reference angle of 45 degrees. So they all belong in the same category with each other. And they're all going to have the same sine and cosine values, except you just have to figure out which ones are positive and which ones are negative. So if you read it directly from the unit circle, you were just picking off the ones where you saw x-coordinates of negative square root 2 over 2 because that was the cosine, negative square root 2 over 2. So it was at 135 and 225 degrees. Like I said, this is going to take a lot of practice, and you've got a lot of, you really do have a lot of material being thrown at you in these first few sections. Let's look at the next piece. We're almost done with this section. We want to talk about calculator approximations of trigonometric function values. Since our angles are given in degrees, the calculator must be in degree mode. So let's make sure our calculators are all in degree mode. On your calculator, you need to, and I don't know if this is showing up for you, I hope it should be because it's right under the light. On your calculator, to make sure that you're in degree mode, I'm going to clear all this out. You're going to go to the mode button here, and you're going to scroll down twice to where it says radian degrees, and you need to make sure that you've got degrees highlighted and press enter. And then you can back out and go second quit. but that tells me that I'm in degrees, so that's where I need to be for now. Later, you'll be in radians. You're going to be going back and forth, so you're always going to have to pay close attention to which mode your calculator is set to. All right, so again, how did I get that? I just went to mode, and then I scrolled down and scrolled over to highlight degrees, pressed enter, and I'm good. So now I can go second quit, or second mode, and get back out. All right, now, excuse me. The next group of problems, we get to do calculator approximations. So you'll like that. You don't have to worry with the unit circle right now. You can just type them into your calculator. Use a calculator to approximate the value of each expression. So we're going to do sine of 49 degrees, 12 minutes. Okay, you can convert this over to decimal degrees by hand by just doing 49 plus 12 over 360. And that's not hard to do. You could type it into your calculator, and you're going to say sine 49 plus 12 divided by 60, close parentheses, and we get a decimal of 0.75699505557. All right, they didn't tell me how far to carry it out, so I'm going to say that this is approximately equal to 0.75. Let's do, I don't know, I'm just going to go on 6995. Sorry about that. That's where I am. I apologize. You couldn't see any of that. I hope you saw my calculator though. So you had the notes, so you should be able to see it, but we wanted to, we did sine of 49 degrees in 12 minutes. So we typed in sine of 49 plus 12 over 60 and got this decimal. In part B, we want to find secant. All right, well, there is no secant button on your calculator. So, but you know that secant is 1 over cosine. So what you need to do is express it in terms of cosine. You'll say 1 over cosine 97.977. That's what we're going to type in. So we're going to say 1, let me clear this out, 1 divided by cosine, and we put in our 97.977, close parentheses. I get negative 7.205879213. So I'm going to say that's approximately equal to negative 7.2. I don't know how far I'm supposed to carry it out, so I'm just going to carry it on all the way out. Okay, so negative 7.205879213. Part C, we're asked to calculate 1 over cotangent of 51.4283. Cotangent is a reciprocal function. It does not appear on your calculator because all you have to do is remember the original function that it comes from. This is based on tangent. 1 over cotangent is the same thing as tangent. So they're just going to we're going to find tan of 51.4283. And type that into our calculator. Let me clear this out again. Tan 51.4283. That gives us 1.253948151. So I'm just gonna write it all out. 1.253948. 151. I believe you'll be told how far to carry out your decimals in problems like this. I wasn't told in this one, so I'm just writing it all out. Part D, sine of negative 246 degrees. Okay, nothing to worry about here. Remember, the only thing that the negative in front of the 246 means is that you would find it on your if you were to draw this, you would draw it in you'd go in the clockwise direction, this way around. But as far as the computation, there's not really anything you have to be mindful of when you type this in. You're just going to say sine of negative 246, and that gives us 0.9135454576. So I'm getting 0.9135454576. 3.545454576. All right, and that's it for example 8. All right, and then after this, if x is an appropriate number, then sine inverse of x, cosine inverse x, or tanverse inverse x, excuse me, let me say that again. If x is an appropriate number, that means if x is in your domain, then sine inverse x, cosine inverse x, or tan inverse x gives the measure of an angle whose sine, cosine, or tangent respectively is x. So, what is this saying? Basically what this is saying is that if you're asked to calculate sine theta equal some number, instead of being asked to calculate sine of 30, you might be asked to calculate sine theta equals maybe 1, and then you have to solve it for theta. And in order to do that, you can use an inverse function just to cancel out the sine function and calculate the right side of your equation. So in example 9, find an angle theta in the interval 0 to 90 degrees that satisfies each condition. Alright, so in part A, we're going to take sine inverse. If we take sine inverse of both sides of this thing, the inverse is going to cancel out with the sine and just leave us with theta. So you're going to say, I'm going to write it in once just so that hopefully it'll make sense to you. So I'm going to say sine inverse of, and then I'm going to do the sine theta. So apply the sine inverse function on the left side of your equation, and then apply your sine inverse function on the right side of your equation. Okay? Just like squaring and square roots, they cancel each other out because they're inverses. You saw this in 171 when you were doing like natural log of e. They were inverses, they canceled each other out. So that's the idea here. These cancel each other out, and you're left with theta equals. And then this can be typed into your calculator. So how are we going to type it in? Looking at your calculator, find your sine button here, and above it you should see sine inverse. So in order to use this feature, you need to go second sine, and that gives you sine inverse. And now you can type in the number that you were given. So we want to find sine inverse of 0.96770915. That gives us an answer of 75.3999534. This time I'm just going to say it's approximately 75. So approximately 75 degrees. And I don't want to have the equals and the approximation, so I'm get rid of that. So I got theta is approximately equal to 75 degrees. Okay, for part B, secant theta is 1.0545829. Okay, again, remember secant is not on the calculator, so you can't just type in secant inverse. But what you can do is express this in terms of cosine, because we know that secant is the reciprocal of cosine. So if we write this, we know that this is 1 over cosine theta equals all this. Be careful not to confuse reciprocals with inverses. Remember, reciprocals are when you're flipping the fraction over. An inverse function is something that will cancel out with its original function. So just be careful not to confuse those two. Alright, now how do we solve this for cosine? Well, if you multiply both sides of this by the common denominator, cosine theta, that's going to give you 1 equal this long decimal times cosine theta. And then I need to divide both sides by the decimal. So I've got 1 over 1.0545829 equals cosine theta. Alright, now that I've got it expressed in terms of cosine theta, I'm ready to do my inverse function. So I'll take the inverse of, I'm going to do cosine inverse of this fraction. So I'm going to type that into my calculator. So I'm going to say second cosine, and that gives me my cosine inverse function. And then inside I'm going to type 1 divided by 1.05458829, close parentheses. And that gives me an answer of 18.51470432. I'm going to say that's approximately 19 degrees. Alright, so I'm going to say it's approximately 19 degrees for my answer. Approximately 19 degrees. Again, that decimal that I got was 18.51470432. And I think that's it. I think that this completes section 5.3. So again, 5.2, 5.3 were very long, had a lot of material in them. You've got a lot of studying to do to make sure that you can do the problems that you'll be asked to do moving forward in this course. Make sure that you know this unit circle. Make sure that you at least know this first quadrant. If you know this first quadrant, as you've seen, you can find everything else using reference angles and all silver teacups. So study this, and we're going to be doing quizzes on the unit circle coming up very soon. Alright, but thank you, and we will be working on this more in class.